We will continue with the data visualization in this lab. We will look at the relationship between two or more variables using a scatter plot and bubble plot. Sometimes we need to show how multiple variables are related with each other. Example, how predicted values are similar to the real values, how height is related to weight, and etc. etc. Scatterplot is often the first type of plot to try out. The easiest way to plot a scatterplot is with matplotlib. So let's define a figure first. To do that, we pass the command let fig equal plt.figure open and close bracket. Then we will plot plt.plot of CC rating, comma, gross vehicle mass, comma, k dot, comma, label equal vehicle mass, comma, alpha equal 0.1, and we want to see the legend, so we will pass the command plt.legend open and close bracket. So we see that the legend is vehicle mass, and on the horizontal axis we have the CC rating, and on the vertical axis we have the gross vehicle mass. So now we already defined the figure, so we don't need to do that again. Now plt.plot df CC rating and y-axis show gross vehicle mass, and type is k dot, label equal vehicle mass, alpha equal 0.1, and on top of that we will plot by another graph, plt.plot of CC rating, comma, power rating, comma, r dot, comma, label equals power rating, and we want to label the x-axis and the y-axis by passing the command plt.x label CC rating, plt.y label gross vehicle mass, and we will pass the command plt.legend open and close bracket. So we see that for the power rating, it seems to be a straight line at 0, and there is one dot which is not 0 for the gross vehicle mass. So for the CC rating and the gross vehicle mass, yes, so we are labeling the y-axis as gross vehicle mass, but we have plotted the second graph which shows power rating. So we have gross vehicle mass shown by the gray and black dots, and the power rating is shown by the red dots. So this is PLT Y label. We cannot do gross vehicle mass. In general, we can put values. Okay, or we can use Seaborn with function reg plot that will show the regression plot. Use the function reg plot to make a scatter plot. sns.regplot of x-axis shows CC rating and y-axis equal y equal power rating, and it's like this, and we have a regression line in between. That's the best fit line. So we can see that as CC rating increases, the power rating decreases to 0. So the power rating increases and then decreases to 0. As we can see, SNS.reg plot by default include a regression fit of the two variables that we are plotting. We will remove it to make it a scatter plot similar to what we had in matplotlib. Use the function regplot to make a scatter plot. So we try to do the same scatter plot, but we want to remove it. So SNS.regplot of x equals CC rating, y equal power rating, comma fit underscore reg equal false. So that will remove the regression line. The main danger with scatter plots is overplotting. When the sample size gets big, cycles tend to overlap, make the figure unreadable. For instance, when we plot First New Zealand registration month and First New Zealand registration year. So let's look at the first few lines of the cars data frame. So we see that there is column with First New Zealand registration year and First New Zealand registration month. So let's do the reg plot. SNS.regplot of x equal First New Zealand registration month and y equal First New Zealand registration year gives us this. So we can see that for the months we have First New Zealand registration year. So for example, for the month 2, which is February, the First New Zealand registration year starts from about 1975 and it goes up to about 2011. In this case, it's important to try thinking of other kinds of plots that would allow us to see better patterns from the data. Let's try again with the KD plot in Seaborn, but this time we plot for both First New Zealand registration month and First New Zealand registration year. Two-dimensional density plot. SNS.kde plot of data equal DF cars of First New Zealand registration month and First New Zealand registration year. By surrounding these columns with a double square bracket, we are forming the data frame. So if I can show that to you, just a second. So DF cars. So we have double square bracket around the columns. So that forms a data frame like this. It's in a table form. So data equal DF cars of double square bracket First New Zealand registration month, First New Zealand registration year, palette equal reds, shade equal true. So that will give us First New Zealand registration year, which is the light red one, and the dark red one is First New Zealand registration year. First one is First New Zealand registration month, and the second one on the right is First New Zealand registration year, and the densities are plotted on the y-axis. So we can see that for the First New Zealand registration year, the density is going higher than for the First New Zealand registration year. Seaborn allows us to change a few options. For instance, the color and the shading of this graph. Let AX equal SNS.kde plot of data equal first registration month and Fish New Zealand of data equal subset of DF cars, the cars data frame for month and the year. And pellet equal marker, shade equal false, and we set the X label and the Y label by passing the command ix.set bracket X label equal month, comma Y label equal year, and we get this. So the dark blue one is for the month, and for the light blue one it's for the Fish New Zealand registration year. It's hard to see still, so let's try again with a combination of two-dimensional and one-dimensional kernel density functions. So again, let's plot two-dimensional density plus one-dimensional kernel density. By passing the command sns.joinplot of X equal Fish New Zealand registration month, Y equal Fish New Zealand registration year, pellet equal blues, shade equal true, kind equal KDE. So we get this. For the Fish New Zealand registration month, we can see the density rises and then falls and remains at the top level for some time. And for the months which is from 2 to 12, the density remains almost very similar. And for the registration year, there is a peak. There are 3 peaks. So the highest peak is from 2000, in between 2000 and 2010, and then the other peaks are around 1990 and 1980. As we can see, the x-axis, which is for month, goes from -2 to 15, which is not correct. Could we try changing the axis to plotting 1 to 12 only? Let's look at the columns of DF cars. So we have in the cars data frame, we have columns showing basic color, body type, CC rating, Fish New Zealand registration year, Fish New Zealand registration month, gross vehicle mass, import status, industrial class, make, model, motive power, number of axles, number of seats, New Zealand assembled, original country, power rating, previous country, submodel, TLA, transmission type, vehicle usage, vehicle year. Let's show the motive power, and also we want the months to be from 1 to 12. That is from January to December. So we'll pass the command sns.joinplot of data equal DF cars, X equal Fish New Zealand registration month, Y equal Fish New Zealand registration year, He equal motive power, shade equal true, kind equal KDE, X limit equal bracket 1, 12. So we see that motive power is 0, diesel and petrol. So the green one is for 0, which the motive power is not entered. And the orange one is diesel. The motive power is diesel. So the Fish New Zealand registration year for the diesel were in the month January to February was from year 2000 to 2000, about in year 2000, and in about 2012. 2011 to 12. Now for the month June, Fish New Zealand registration year was sometime in 1985 to 1990, and then from 2011 to 2012. And then the petrol. The petrol was the petrol vehicles were first registered in the month of January from 1972 to about 2000. And in December, the first New Zealand registration year was in about 1973 to about 1992. So we can see that the first New Zealand registration month for the petrol vehicles, the density is quite high for all the months compared to diesel. And for registration year, also the petrol vehicles registration was higher than for diesel. So now we remove the data with zero motive power, and then we replot this graph. Let temp equal df subset of df cars for motive power not equal to 0. Let's do the two-dimensional density plus marginal distribution once again. I will pass the command sns.join_plot of data equal this subset which doesn't include motive power equal to 0, and x equal first New Zealand registration month, y equal first New Zealand registration year, and hue equal motive power, and shade equal true, kind equal KDE, XLM LIM, X limit is from 1 to 12. So we see this. Again, the motive power 0 is removed and we are left with diesel and petrol. The diesel vehicles are registered for the month from 1 to 12, and for the year from about 1988 to about 2015. And there is a little bit this secular part shows little bit of registration in the months from about 3 to 6 for the year 1978 to 1981. We learned that we can achieve a scatter plot through sns.regplot function. But another way to plot scatter plots in Seaborn is simply use the function scatterplot. Use the scatterplot function to build the bubble map. sns.scatterplot of x equals CC rating, y equal power rating. So so we can see this. With this, each dots can have a different size. But thus we can show another dimension of the data, and the plot is called a bubble plot. Use the scatterplot function to build the bubble plot. So sns.scatterplot of data equal df cars, x equal CC rating, y equal power rating, size equal gross vehicle mass, and legend equal force, size equal 20 to 2000. So the size shows how big the gross vehicle mass is. So for the CC rating 0 and power rating around 0, we have a big bubble there. And we have big bubbles for CC rating around 7,000, say 800 to about 9,000, and power rating from 0 to about 100. Besides the size of the data points to show its gross vehicle mass, we can also color the points differently to show another dimension, or simply emphasizing the difference in the gross vehicle mass again. Could you try coloring each data point using the value of gross vehicle mass? So let's have a look. Use the Scatterplot function to build the bubble map. SNS Scatterplot data equal cars data frame, X equals CC rating, Y equal power rating, size equal gross vehicle mass, hue equal gross vehicle mass, legend equal force, sizes equal 20 to 100, 20 to 2000. So we see this. What if we do legend equal true? What does this give? So legend equal true, we can see that the very big bubbles show 20,000 to 25,000. So the small bubbles, they show the gross vehicle mass of 0, and then 5,000, 10,000, 15,000, 20,000, 25,000.